Hello, future RMTs. Welcome to our discussion about amoebas. Our learning objectives and or learning outcomes today is to recall the morphology, life cycle, pathogenesis, epidemiology of different amoebas, and distinguish the diagnostic features of each amoebas. Okay, to start with, let us define what is protozoans. Protozoans is the lowest form of animals. Okay? Being an animal, it is classified under kingdom Protista. Protozoans is also classified as uh, unicellular organisms or unicellular microorganisms. There are three significant medical phylum, no, under protozoans, which are the Sarcomastigophora, the Silifora, okay, and of course, we have the apicomplexa. And if each of it will be discussed to you as we go along. Okay, so we have the sarco, the silifora, and the apicomplexa. So what is with this one? No? When we said sarcomastigophora, if you still remember in our first discussion, we said that sarcomastigophora is divided into two. We have the sarcodina, and we have the mastigophora. No? Under Sacordina, we have there your amoebas. Again, amoebas can be spelled with OBAS, okay? Or as simple as this one, amoebas, okay? And this is a protozoan. Under Mastigophora, we have there your flagellates and hemoflagellates. These three are all considered Sarcomastigophora, okay? Please don't be confused. This tree is considered as Sarcomastigophora. Now, what is the main difference between amoebas, hemoflagellates, and flagellates? Okay. If we are going to discuss the major or one of the difference between these two, they are all motiles. They are all motile, rather. They are all motile. The only difference is that the organ of locomotion for amoebas is what we call the pseudopods, and the organ of locomotion for flagellates and hemoflagellates, from the word itself, flagella. We have here your flagella as the organ of locomotion. For ciliates, now we have there the Silphora, and they have what we call a cilia. Under Apicomplexa, we have the Sporozoa, Plasmodium, plus the Tabacia, which we are going to discuss sooner this semester. The focus of this discussion will be given to amoebas. Okay? Species of amoebas that occur in human can be divided into three classifications. We have pathogenic, we have commensal, and we also have free living. When we said free living, these are what we call facultative, right? These are what we call facultative. When we said commensalism, they can be found in the human body, but they don't cause harm. Most especially if the human body or the host has an intact immune system which does not allow the antigens of these commensal parasites to cause infection. However, there's a word however, these commensal parasites or commensal amoebas are also capable of causing diseases. And most especially, we have here your pathogenic, which is your Entamoeba histolytica. It is interesting to know that Entamoeba histolytica is the only pathogenic intestinal amoeba. I repeat, it is interesting to know that Entamoeba histolytica is the only pathogenic amoeba, pathogenic intestinal. I should include intestinal amoeba. Why? Because the rest is what we call commensals. On the other hand, Naegleria fowleri and Acanthamoeba species, even though that they are free-living, they can also be considered as pathogenic amoebas. But, okay, Naegleria fowleri and Acanthamoeba species are what we call extra-intestinal amoebas. Okay? Because this amoebas does not invade intestinal tract. So we have here your Entamoeba dispar, Entamoeba boshkovsky, no? Entamoeba hartmanni, Entamoeba coli, Entamoeba polecki, no? Si Entamoeba polecki, it's interesting to know that this is amoeba of pig and monkey. Okay? Entamoeba polecki is a amoeba of pig and monkey. We also have here your Endolimax naina and your Eudamoeba buchlei. Now, again, amoebas can be spelled as Amebas or Amoebas or Amebae. No, Amebae. They are all the same. Again, like what I've said a while ago, our amoebas are motile, no, because they are equipped with this extension in their cytoplasm, and that is what we call pseudopods. Pseudopods is known as the false fit. Okay, again, amoebas are motile because they are equipped with the extension in their cytoplasm, and they have this ability to extend their cytoplasm called as the pseudopods. Pseudopods. And these pseudopods is what we call false fit. Okay. Now remember that generally, generally among all protozoans, generally there will always be a exemption in the general rule. Generally, amoebas, or should we say protozoans, has two distinct morphological forms. And what are those? We have the trophozoites and the cyst. Now, we have the trophozoites and the cyst. Now, what is the difference between trophozoites and yeast? Let's discuss first trophozoites. Remember, guys, the trophozoite is the feeding stage. It is the morphological form that possesses pseudopods. Therefore, trophozoites is what we call moting. This is also the morphological form or the stage of the morphological form of our amoebas, wherein it is capable of what we call multiplication. And the multiplication of our trophozoite, of our amoeba, is through what we call binary fission. No? What is with binary fission? If you are going to recall, or di nyo pa pala discuss, if you are going to discuss or read it in your book in bacteriology, the way how our protozoans multiply is almost the same way on how our bacteria multiply, and that is what we call binary fission. To make it simple, we have here a cell, and this cell will cleave, okay, will cleave. What material is present on the mother cell will also be the material that will be present on the cell that will have to undergo division or cleavage. Okay, until such time that the cleavage will split the two cells into two identical cells. That is what we call binary fission. That's the simplest way to explain binary fission. Okay, so like what I've said, trophozoites are equipped with pseudopods, and there are what we call motile. However, It is interesting to note that trophozoites are delicate and fragile, which means, or which is the reason why, it's the reason why trophozoites are rare to see in fecal samples. They are rare to see because they are susceptible to the outside environment. No? They are sensitive to the outside environment. And you might wonder how trophozoites survive or how amoebas survive in our intestine, in our stomach. Provided, having said that trophozoites are easily destroyed by gastric juices. We have what we call the morphological transformation from trophozoites to cyst so that these amoebas will be able to survive in our gastrointestinal tract, okay? Which we're going to discuss later. Aside from trophozoite, we have what we call the cyst. In make it simple, cyst is the other way of trophozoite. If trophozoite is the feeding stage, if trophozoite is resistant or sensitive in the external environment, cyst is resistant. Yeah, resistant in the outside environment, while because they have what we call a thick protective cell wall. Like what I've said, like what I've said a while ago, trophozoites are easily destroyed by gastric juices. Thus, it requires trophozoites transform into cystic stage so that these gastric juices will not destroy our trophozoites, our amoebas. Cyst is capable to resist the gastric juices of our stomach because of this thick protective cell wall that they possess. Trophozoites are motile, cysts are non-motile because they have no ability to extend their cytoplasm. They don't have what we call pseudopods. Therefore, we can simply say that pseudopods is true to amoebas, most especially to trophozoite form of our amoebas. Now, I want you to remember this one. Remember me. Nuclear characteristics of trophozoites are basically identical to those of their corresponding cysts. What does it mean? It simply says that what will you see in trophozoite is most likely present also in the cystic stage. Okay. Now, I have a question. I will back to trophozoites. Okay. There's a question in our board exam, and the question goes like this: Trophozoites, I don't know, stool stained with iodine. Okay. A stool is stained with iodine, comma. What will be the color of trophozoites? A. Yellow brown. B. Brownish yellow. C. Yellow. D. None. Okay. A stool stained with iodine. Iodine is what we call the Lugol's iodine. Okay. What will be the color of the trophozoites? A yellow, A yellow brown, B brownish yellow, C yellow, D none. If your answer is yellow brown, you're wrong. If your answer is brownish yellow, you are wrong. Kasi parehas lang naman halos yun, yes. Pero mali. Ano ba ang kulay ng lugol sa iodine? O yung simpleng iodine na meron kayo sa bahay? Yung betadine. Ano bang kulay niyan? Brown na parang nag-yellow. Yellow na parang nagpa-brown. So, ibig sabihin, brown or yellow color will impart to the stool, direct fecal smear of the stool, if you're going to use iodine. The question is, what will be the color of trophozoites? The correct answer here is none. A, bakit none? Remember what I've said. Trophozoites are easily destroyed, no? And they are susceptible to the outside environment. Trophozoites can be seen in stool, in direct fecal smear, if we are going to use NSS or saline solution. Because saline, being hypotonic solution, hindi naman siya nag-destroy. It will not cause shrinkage nor swelling of the cells. On the other hand, iodine, particularly Lugol's iodine, destroys our trophozoite. So, ang sagot dyan, none. Okay? So again, going back, sir, if we cannot use Lugol's iodine to demonstrate our our trophozoite, then what should we do? We can use nuclear stainings or stain. Again, stains will give us color, and this color will give us a identification mark, a diagnostic mark to identify the parasite. So how about for cyst? Is cyst or is iodine capable to impart color to cyst? Yes. A yellow brown, a yellow color, or a brownish brown, a brownish yellow color can be imparted to our cystic stage. Okay? And and to tell you honestly, if we are going to use Lugol's iodine as compared to our what you call this, as compared to our NSS, aba, mas maganda naman yun pagdating kay cyst. Why? Because it will give somehow color and will be able to identify cyst versus PMNS. Polymorphonuclear. Okay? But by the means of staining, we can now see, no, the identical uh, what you call this, characteristics of trophozoites and toxics. Now, I said a while ago that our trophozoites, no, are sensitive to the gastric juice, and there are transformation from cyst to trophozoite and trophozoite to cyst, or vice versa. So, what is this? When we said excitation, no, when we said excitation, this is a morphological transformation or simply a morphological conversion from a cystic stage going to a trophozoite stage. And it usually occurs in the endocecal area of the intestine. Remember, excitation from cyst to trophozoite. And when we said encystation, that is the other way around, from trophozoite to cyst. Now, it occurs when environment becomes unacceptable for trophozoites to continue, alisin natin yung S, to continue multiplication. Like for example, no, yung ating environment is not suitable for trophozoites to survive, then they will transform into what we call cystic stage. There are factors that triggers encystation, which is the morphological transformation of trophozoite to cyst. And what are those? Overpopulation. Remember that this trophozoites is the feeding stage. If there are an overpopulation of trophozoites, there will be decrease in food supply and oxygen. Thus, it requires them to transform into cystic stage because they are not the feeding stage. And if there is a decrease in pH, meaning to say the environment becomes acidic, then it will trigger them to form into a cystic stage. Like what I've said a while ago, replication can only occur in the trophozoite stage, and that is accomplished by what we call asexual reproduction. That is what we call binary fission. Now remember, in science, division is in science division means multiplication. Ano daw? Division, if you divide, it means you multiply. Okay. So for laboratory diagnosis, since most of our amoebas are intestinal protozoans, they require stool as the sample of choice. I will not go deeper on this one because I've already explained this to you. Remember, trophozoites are usually found in soft, liquid, and loose stool, while on the other hand, we have the cyst for form. But there are cases that cystic stage can also be seen into loose or soft. Soft. Okay. So remember, we have the saline wet preparation and the iodine wet preparation. Again, saline wet preparation allows us to see the motility of our amoebic trophozoites. However, the demonstration of amoebic trophozoites in direct fecal smear can be seen in rare instances. While for iodine wet preparation, it gives color to our cyst and as well as the background for easy identification of the nuclear structure of our cystic stage. However, the downside of our iodine well preparation, like what I've said a while ago, it destroys our thrombocytes. Now the question is, why is it important to diagnose pathogenic amoebas, non-pathogenic amoebas? Sabi mo sila kanina, they are commensal. So what is the reason why we have to do the, what is the reason why do we have to identify them? Why do we have to diagnose them? And the only reason behind that is because such as contamination or ingestion of a food that is being contaminated. Okay. Therefore, the presence of these protozoans, such as that you ingested, no, contaminated foods. Now, to start with, let's discuss first what is Entamoeba histolytica trophozoites. Now, I want you to take note, and it is important for you to remember that in amoebas, you have to identify the morphological forms. Not only in amoebas, but also in helminths. No? You have to be specific on what is the morphological form seen. If that is a trophozoite, then let it be trophozoite. If that is a cyst, then let it be cyst. Okay. Remember also that the correct way of writing the name of the parasites. Okay. It is my golden rule that in my class you are not allowed to write E histolytica. You are not allowed to write that. It is acceptable, yes, but you are not allowed. You should write it with complete genus and complete species. Now, like what I've said, let's discuss first what is Entamoeba histolytica trophozoites. No? Entamoeba histolytica trophozoites is typically 8 to 65 micrometers with an average size of 12 to 25 micrometers. Okay? It has a rapid unidirectional progressive movement and with a small central mass of chromatin. Okay? And it is also equipped with what we call caryosome. Caryosome is also known as the caryosomal chromatin, which can be eccentric or fragmented caryosomal material. Now remember that we have here your Entamoeba histolytica, the trophozoite form of Entamoeba histolytica in comparison to the trophozoite form of our Entamoeba coli. Now, the pre-cystic stage or the immature cystic stage of our Entamoeba histolytica and Entamoeba coli, as well as the right, or simply that is the mature cystic stage of our Entamoeba histolytica. Now, what is important to know and to remember about Entamoeba histolytica trophozoites? They appear ground glass appearance, the cytoplasm, as you can see, This is the ground glass appearance of the cytoplasm of our Entamoeba histolytica trophozoites. And it is important to note and to remember that the trophozoites of our Entamoeba histolytica has an ingested RBC on its cytoplasm. Now, you might wonder or ask, saan nanggaling yung ingested RBC? No? Na Entamoeba histolytica. Take note that this ingested RBC of our Entamoeba histolytica trophozoites came from the ulcerations that is caused by this parasite. And this RBC serves as their food. Okay? Take note. Now, take note. The cytoplasm of the Entamoeba histolytica trophozoite has ingested RBC, and that is true only to your Entamoeba histolytica. On the other hand, we have here your Entamoeba histolytica cyst. No? Entamoeba histolytica cyst is spherical to round in shape. If we are going to compare, no, yung ating Entamoeba histolytica trophozoites, or this is also true with other trophozoites. Yung trophozoites natin rugged, yung trophozoites natin hindi uniform yung kanyang shape. It varies. No? Why? Why it varies? Because they have what we call the pseudopods. They are capable to extend their cytoplasm. Okay? Unlike here in our cyst, yan na yan eh. Bilog siya kung bilog. Ovoid siya kung ovoid. Spherical siya kung spherical. And it is important to know and to remember that our Entamoeba histolytica cyst is spherical to round. Typically, 8 to 22 micrometers on average, 8 to 22 micrometers, and an average size of 12 to 18 micrometers. You might wonder or ask, so it is important for us to remember the size of our cyst and trophozoite for each Amebas? The answer is yes. Okay. So this is the cystic stage of our Entamoeba histolytica stained with Lugol's iodine. Now, this is the nucleus or the nuclei of our Entamoeba histolytica cyst. A while ago, we said, no, in the previous slide, we said that typically what is present in the cystic stage or what's present in the trophozoite stage is basically present in our cystic stage, but that is not true with the RBC ingested by the trophozoite of our Entamoeba histolytica. The ingested trophozoites of the ingested RBC of our Entamoeba histolytica trophozoite can only be seen in trophozoite. It can't be seen in our Entamoeba histolytica cyst. Okay, to make it deeper, our Entamoeba histolytica is classified as a quadrinucleated cell or quadrinucleated entamoeba or amoeba. What do we mean by quadrinucleated? It means that it can possess to 1 to 4 nuclei. Kanina, I've shown you this one. This is the nucleus, no nuclei. 1 to 4, kaya na magkameron. Okay. The size of Entamoeba histolytica somehow similar to the size of our polymorphonuclear cells. That's why these polymorphonuclear cells becomes a what we call confusers. Kung siya ba talaga ay Entamoeba histolytica or a WBC. How are we going to differentiate that? No? Yung mga lobes. May lobes ang ating WBC. Lobes, hindi lobes. May lobes. Ang ating cyst, wala siyang lobes. Meron siyang nucleus. Ang ating WBC, wala na naman yung nucleus, pero may lobes. Okay. So remember, this is a quadrinucleated, no, mature, 1 to 4. Okay. Now, remember, RBC, bacteria, and other debris are not found on cytoplasm of our Entamoeba histolytica. Again, RBC can be found on the cytoplasm of our Entamoeba histolytica trophozoite. Okay. Chromatoid bars are present that contains the condensed RNA materials of our Entamoeba histolytica, as well as the glycogen mass, which serves for the food storage of our Entamoeba histolyticus. Since they are non-feeding stage, so dapat meron silang glycogen mass for the storage of food. In this table, we have here the showing you, the difference between Entamoeba histolytica, Trophozoites, and Cyst. Again, remember, the Trophozoites has ingested RBC. It can also have a bacteria and other debris that could be present into its cytoplasm. However, no, yung ating cyst, wala po siyang ingested RBC, and it has a chromatoid bars, rounded ends, and young cyst, and diffuse glycogen. Since Entamoeba histolytica is a intestinal parasite, no, the most commonly used sample is stool. Having said that stool is the most common sample, it is very very common na ang kanyang diagnostic test is fecalysis. However, there are also culture media that can be used for our Entamoeba histolytica, and that is your TYIS 33. Now remember, this is a culture media. A culture media is a synthetic environment that allows our parasite to grow. On the other hand, we can also use ELISA test, no, EHEIA, wherein this is a immunological test, no, that detects the antigen of our Entamoeba histolytica in the uh, stool sample. Now, the stool sample might be negative in, pwede siyang negative saan? Sa parasite. Tapos positive dito. Pwede po ba yun? Yes, it could be. Why? Most especially if the stool, no, yung portion ng stool na nakuhanan mo, nandoon yung lowest amount of the inoculum. Or hindi pa napapas through feces yung mga protozoans, yung Entamoeba histolytica present in the stool. But antigens of the parasite is already detectable. Now, aside from EHEIA, no, we also have the direct or indirect hemagglutination, HIA, gel diffusion precipitation, and indirect immunofluorescence. The sample of this one varies kung sakit na gagamitin. Usually, kung antigen and immunological, pwede po dito ang blood sample. No? But most common sample used to identify the presence of our Entamoeba histolytica is no other than fecalysis. Having said that fecalysis is the diagnostic test, it is also important for us to remember the life cycle of our Entamoeba histolytica. Now remember, the mode of transmission of Entamoeba histolytica is the ingestion of contaminated food or drink with the cyst of Entamoeba histolytica. As we all know, and I want you to take note that the cystic stage of Entamoeba histolytica is the infective stage. What do we mean by infective stage? When we said infective stage, this is the morphological form of the parasite that causes immunologic response to our body. It causes infection to our body. It initiates, siya yung mag-initiate ng infection. Remember, the mode of transmission of Entamoeba histolytica is ingestion of contaminated food, particularly the presence of acids. Now, since you ingest a food contaminated with the cyst, this cyst will enter our body through our mouth, going to our intestine. So what will happen? In the intestine, no? In the intestine, ano yung sunod na mangyayari? There will be what we call encystation. No. I'm sorry. Ito pala muna. In the intestine, in the stomach, going to our small intestine. I'm sorry. No? From stomach, remember, ano yung nandito? Cyst. Yung cyst mo, meron siyang thick protective cell wall that allows them to survive in the gastric juice, in hydrochloric acid, which is an acid in our stomach. Okay. Now, the cyst will enter into our small intestine. And upon entry in the small intestine, our cyst will undergo what we call encystation, which is a morphological form from cyst to trophozoite. Now, these trophozoites will invade our intestine. So, will invade our intestine, causing what we call ulcerations. Causing what we call ulcerations. Kaya, yung stool sample ng mga pasyente na mayroong amebiasis, meron ding presence ng RBC sa stool. Bakit? Because of the ulcerations that is caused by our Entamoeba histolytica trophozoite. Now, these invasions, this site of invasions, no? Syempre may sugat dyan. Anong mangyayari dyan? This abscess, no, will promote what we call bacterial infection. Aba, ay ang malas mo naman. You already have the parasite and you develop also bacterial infection. How is it possible? It is possible since there are normal flora, normal bacteria that resides in our intestine. And the site of invasion, these ulcerations allows them, oh, this is our opportunity to invade and to cause infection also aside from causing parasitic infection. Okay. Now, ngayon, ano yung mangyayari? Once our trophozoites invade, no, and cause ulcerations, ano yung mangyayari? It will allow our trophozoites to entry and to disseminate into other organs. No? Madi-disseminate siya. And it is also capable to go into our blood vessel. Kaya siya pwede magkameron ng tinatawag na extraintestinal lesions. And the most common organ involved in what we call extraintestinal parasitism is no other than our liver. Bakit? Lahat ng dugo dumadaan sa liver. Okay? Lahat ng dugo dumadaan sa liver. And our liver, no, yun yung major organ involved in our extraintestinal parasitism. And liver can develop abscess. Liver amoebic abscess. Aside from that, brain can also be invaded by our Entamoeba histolytica, meaning to say it is not limited only for being an intestinal parasite because it is also capable of invading other organs in the body. Even your lungs, pulmonary abscess. Our Entamoeba histolytica is also capable of causing pulmonary abscess. Thus, sputum can also be used as what we call sample. Pero before you assess the presence of Entamoeba histolytica in the lungs, ay bakit hindi mo na sa stool? It is acceptable to say that sputum can be useful to detect the presence of Entamoeba histolytica if the patient is suspected of having an amebic abscess or pulmonary abscess caused by Entamoeba histolytica. Pero bago mangyari yun, stool muna. Okay? Ulitin natin, kumain ka lang ng maruming pagkain na mayroong contamination, mayroong presence of Entamoeba histolytica cyst. So Entamoeba histolytica cyst pumunta sa iyong intestine. Why is it quite capable of proceeding to your intestine? Eh bakit hindi siya na-destroy? Because cyst has this thick protective covering. It can survive on that acidic environment. Mag-e-exist siya. Mag-e-exist siya rather. Mag-e-exist itong si parasite na ito. Para saan? Abay para siya ay magkaroon ng nutrients. Kasi kailangan niya mag-survive in your body. Parasite siya. Ano ba ang definition natin ng parasite? It lives in the expense of the host. Survives in the expense of the host. Eh, di mag-morphological transformation. This morphological transformation will allow the trophozoites to move because they have the capability to extend their cytoplasm, and that is what we call your pseudopods. Move, move, move. Going to the site where will invade, where will cause ulcerations, and that ulcerations will allow them to disseminate in the other organs. That ulcerations will allow the parasitic infection to cause secondary infection, and that is bacterial infection. That ulcerations is the reason why there is a presence of RBC in the stool sample. Okay? Now, once the environment is not suitable for the trophozoites to survive because nakuha niya na yung nutrients. Yung tao, nag-defecate na. Yung tao, nag-LBM na. Then, the environment starts to become dehydrated. Eh, ano yung mechanism nila? Eh, di mag-morphological transformation na naman from being a trophozoite going to a cystic stage. And that is the time that it will pass through the stool sample. No? And that is the time na nagkakameron ng stool sample, ng presence ng Entamoeba histolytica sa stool. Now remember, the presence of Entamoeba histolytica in the stool can be a trophozoite, can be a pre-cystic stage, or the cystic stage, which is the mature, the well-grown. Okay? Remember, guys, that Entamoeba histolytica can survive in water up to 30 days, 9 to 30 days. In a moist, cool conditions, up to 12 days. Okay? If you were able to read the book, on the part of Entamoeba, the spar, the book said it has the same life cycle as of our Entamoeba, the spar. They have the same life cycle. They have the same mode of transmission. But what is the difference? Entamoeba, the spar, is non-invasive. Entamoeba, the spar, is not capable to cause clinical disease. And take note of this. Entamoeba, the spar, is almost similar to our Entamoeba histolytica. Okay? Yeah. I just want to show you the other way of showing the life cycle of our Entamoeba histolytica. From ingestion, no, going to stomach, capable to survive in the stomach, going to our intestine, encystation from cyst to trophozoite, morphological transformation, multiplication of our amoebas, invasion, dissemination, causing infection, and here comes the dehydration. No, kapag nag-disseminate, saan ka din magpunta? Sa lungs, sa liver, sa brain. Even in tissue, it is also capable. No, that's why it causes necrosis then sometimes. So after that, no, after the environment is not suitable for trophozoites to survive, it will morphologically transform back to cyst, and it can be defecated. Remember that the morphological forms that can be seen in stool is not only cyst. Trophozoites also. Ayan. Paulit-ulit kong sinasabi at para paulit-ulit niyong tandaan at hindi niyo malimutan, Entamoeba histolytica is the only pathogenic amoeba. However, the symptoms may vary on the location of the parasite and, of course, the extent of tissue invasion. Okay? There are cases that Entamoeba histolytica appears asymptomatic. What are the reasons? Parasites is low in virulent strain, inoculum is into the host slow, and the immune system of the host is intact. Okay. Now, what are the conditions associated to Entamoeba histolytica? Siyempre, intestinal amoebiasis, intestine E, amoebic colitis, ameboma, amoebic dysentery, and we have the bacterial infection. So let's go. What is amoebic colitis, amoebic dysentery, and so on and so forth. When we said amoebic colitis and amoebic dysentery, this is present with gradual onset of abdominal pain, diarrhea with or without blood. But most, diarrhea with or without blood. But in cases of amoebic dysentery, there is a presence of what we call RBC. Okay? A mucoid sample is usually seen. Fever is not common, and some may have intermittent diarrhea. Wala. Kala mo, wala. No? Amoebic dysentery is different from what we call bacillary dysentery. Amoebic dysentery is caused by Entamoeba histolytica. Ano naman po yung, ayan, yan, di ba? Masarap. That is the mucoid sample ng stool. Masipon-sipon, malagkit-lagkit. And that area contains the parasite. Ooh, I would have said amoebic dysentery is different from bacillary dysentery. Bacillary dysentery is caused by bacillus, bacteria. And what are those bacteria? Shigella, Salmonella, Campylobacter, Yersinia, and enterovasive Escherichia coli or A. Okay, again, we have your Shigella, Salmonella, Campylobacter, Yersinia, enterovasive Escherichia coli. Ang bilis naman, sir. Make it slow. Shigella, Salmonella, Campylobacter, Yersinia, and enterovasive Escherichia coli. How about Ameboma? Ameboma is mass lesions with abdominal pain and a history of dysentery. Ameboma is mistaken as carcinoma. No? Hindi naman po siya carcinoma. And maybe asymptomatic yan. Merong lesions with abdominal pain because of an amoeba history. Now, I've said that secondary bacterial infections is common. Bakit? Ito na yung explanation ko kanina dun sa life cycle. Meron kang lesions, meron kang lesions, meron kang bacteria sa tiyan mo, meron kang bacteria sa intestine mo, wow. So, that is the reason why, kung bakit nagde-develop ng bacterial infection. Secondary bacterial infection. Now, like I said, pag nag-disseminate siya into other organs, abscess, ang unang-unang organ na yon ay ang liver. Formation of abscess in the right lobe of the liver. Bakit naman sa right, hindi sa left? Nandun yung, nandoon yung hepatic vein, kung saan unang dumadaloy ang dugo. Papunta sa liver. At doon na-disseminate ang ating Entamoeba histolytica. It is also capable of amebic pneumonitis, pulmonary abscess ang tawag natin. At the same time, it is capable of what we call secondary amebic meningoencephalitis. Bakit po secondary? Or mas magandang tanong, secondary. Ibig sabihin, mayroong primary. Very good ka doon kung naisip mo yun. Kung di mo naisip, isipin mo. May second, edi may first. Kung may pangalawa, may una. No? Primary, secondary, primary amebic meningoencephalitis, PAM. Secondary amebic meningoencephalitis, SAM. Kanino si SAM? Si SAM kay histolytica. Si PAM kay Negleria. Okay? Nakuha mo yun? Secondary amebic meningoencephalitis, histolytica. Primary amebic meningoencephalitis ay Negleria. Aside from that, lungs, no, kasi nga pulmonary abscess eh. Pericardium, heart, spleen, and brain can also be infected. Or brain, ito. Lungs, ito. Okay. Now, what is ALA? ALA is amoebic liver abscess, the most common extraintestinal amebiasis. Now, there's a pain and fever. There is a fever, no, and pain. Okay, in the right upper quadrant of our intestine. Usually, amoebic liver abscess is diagnosed using ultrasound. Meron ata yung, ayan, hindi pala ata, meron nga. This clear area is the amoebic liver abscess. Ayan, yung area na yan. Nandiyan, yung liver. Actually, this is not ultrasound pala eh. This is CT scan of the liver. Okay? Liver is tender and hepatomegaly, 50% of the cases. Now, like what I've said, secondary amoebic meningoencephalitis, this is amebiasis with normal mental status. Okay? This is a amebiasis with abnormal mental status. Nagdideliryo ka because of the infection. Aside from that, our Entamoeba histolytica is also capable of what we call venereal amebiasis. Venereal amebiasis includes penile amebiasis and vaginal amebiasis. Nangyari yun. Okay. This is true with anal sex. No? If there's an anal sex, no? So, the penis is inserted in the anal area na pwedeng mag-deposit doon sa penis ang amoeba. And then into the vagina, that's why it is capable of what we call amebiasis, venereal amebiasis yan. Yung mga lesions na yan, in the penis, like also this one, and in the vaginal area, is what we call venereal amebiasis. Diba? Broad pala si Entamoeba histolytica. Hindi lang pala siya about intestine. Pwede rin siya sa liver, pwede rin siya sa lungs, pwede rin siya sa brain, pwede rin siya sa spleen, sa heart, and even in the reproductive organs. Happy Valentine's Day. Now, this is the drugs for the treatment of Entamoeba histolytica. Usually, the drug of choice is what we call metronidazole. Metronidazole is an antibiotic. No? Metronidazole is also useful sa mga yun. Wait, let me remember. It is also useful in what we call what bacterial infection. Sige, let me remember. Maraalala ko din yan later. Okay. So for Entamoeba hartmanni or hartmanni, this is a 5 to 15 micrometers trophozoite and 5 to 12 micrometers in cyst. Okay, remember, there is also an ingested bacteria but no ingested RBC. There's also a presence of chromatoid bars and diffuse glycogen mass. Okay. Na ano pa yung magandang tandaan dito, Entamoeba hartmanni, yung cyst niya 1 to 4 din. It is also similar to our Entamoeba histolytica, even the shape, spherical to round. Quadrinucleated din po ang ating Entamoeba hartmanni. The laboratory diagnosis includes the fecalysis, no? And the reporting of Entamoeba hartmanni varies in different laboratory protocol. Bakit? Because they are almost the same with Entamoeba histolytica. That's why in some laboratory they report it as the presence of Entamoeba histolytica slash Entamoeba hartmanni. Well, pero considering that Entamoeba hartmanni is non-pathological, chances are that is Entamoeba histolytica. Okay? So this is our Entamoeba hartmanni. No? This is the diffuse glycogen mass. Para siyang nakasmile sa'yo. Binabati ka ng isang, hello, I am Entamoeba hartmanni. Even though that I am non-pathological, you have to remember me. Ganon ang sinasabi ng smile, ng diffuse glycogen mass of Entamoeba hartmanni. Now, Entamoeba coli, ano, ito yung pinaka-common na commensal parasite na nagkakos ng infection. Lahat ng commensal, pwede naman mag-cause ng infection. Pero sa kanilang lahat, yung most common is si Entamoeba coli. Okay? A 18 to 27 micrometers ay larger than our, the cyst of Entamoeba coli is larger than our Entamoeba histolytica. Ito na yung magandang tandaan mo dito. Si Entamoeba histolytica, quadrinucleated. Si Entamoeba coli, yung mature na Entamoeba coli, kayang magkameron ng up to 8 na nucleus. Okay? So again, the laboratory diagnosis is also fecalysis. Usually asymptomatic, but siya yung common. Ito yung magandang tandaan natin. Kapag ikaw ay mayroong Entamoeba histolytica, usually, ano yung mataas? RBC. Bakit mataas ang RBC? Because of ulcerations. Okay? Because of ulcerations. Kapag meron kang Entamoeba coli, ano yung usually mataas? WBC. Okay? Hindi po ito sa duguha, ito po ay saya as a stool. Okay? Pero dapat tandaan, yung Entamoeba coli ay differentiate ng husay sa mga polymorphonuclear cells or even in macrophages. Yan. Ano yung palatandaan kapag Entamoeba coli up to 8? Kung ang nucleus lagpas na ng 4, chances are, si Entamoeba coli na yan. Okay. Entamoeba polecki, this is also spherical to round. Okay. At si Entamoeba polecki naman, isa lang yung kanyang cyst. I mean, isa lang yung kanyang nucleus sa cyst. Okay. There's also ingested bacteria and food particles in our Entamoeba polecki. Okay. Again, laboratory diagnosis is fecalysis. No? Can be associated with diarrhea, but usually asymptomatic. And if it causes infection, then definitely the drug of choice is also metronidazole. This is your Entamoeba polecki. At ano yung magandang tandaan dito? Meron siyang ingested bacteria. Okay? Sa kanyang cytoplasm. And in its cyst, meron siyang tinatawag na inclusion mass. Now, how about Endolimax nana? Tandaan, si Endolimax nana yung slowest. Siya yung smallest amoebic protozoa. Okay? Siya yung smallest amoebic protozoa natin. Okay? And ano pa yung mahalagang tandaan dito? Yung kanyang cyst, unlike kay histolytica, kay na Hartmanni, kay coli, kay polecki, siya ay ovoid and ellipsoid ang kanyang cyst. Yung mga nauna, they are spherical and rounded. Pagdating po kay Endolimax na one of the key characteristic or feature is yung kanyang ovoid shape and also the blood-like caryophyte. Next is we have your Amoeba bochliae. Okay. It is also ovoid and ellipsoid. Teka lang sir, triangular, other shapes? Yes, this is possible. Okay. And Amoeba bochliae, meron lang din siyang one na nuclei. No? Peripheral chromatins are absent. Again, iodine wet preparation, useful for Amoeba bochliae. No, tandaan mo, ioda, edi iodine wet preparation, fecalysis po. Usually asymptomatic, pero pag nag-cause ng infection, ang gamot ay metronidazole. And remember, no, meron siyang large glycogen vacuole. Meron siyang large glycogen vacuole. Meron lang din siyang isang nucleus. No? Isa sa cyst, isa sa trophozoite. Next is we have Entamoeba gingivalis. Now this is an extraintestinal parasite. And I want you to take note that Entamoeba gingivalis, wala siyang cystic stage. Ano lang ang meron sa kanya? Trophozoite. Okay? No cystic stage si Entamoeba gingivalis. Okay? Sa kanyang cytoplasm, meron leukocytes, hindi leukocytes, no? There's also epithelial cells and what we call bacteria. This is your Entamoeba gingivalis. Now remember that Entamoeba gingivalis can be seen in our oral area. No, from the word itself, gingival. So dun siya. Sa gingival area makikita yung gingivalis. Sputum can be sample. Kasi bakit? Pwede siya mag-disseminate kasi papunta sa pulmonary area. Yes, sputum can be a sample. That's why pulmonary abscess is possible. And it can also be seen in vaginal and cervical areas. I want to make it clear. At medyo baka napapangiti ka dyan. Uy, gingival area, tapos vaginal and cervical areas. Alam mo this. No, mali ang iniisip mo at mali ang nasa isip mo. Bakit maging possible ang vaginal area and cervical areas for Entamoeba gingivalis? Because of the contamination into IUD. Masyado ka namang, no? It resides in the gum line, dyan sa mga tartar, sa ngipin mo, and gingival pockets. And vaginal and cervical area. Bakit? Because of the IUD, intrauterine device. And what is intrauterine device? Yan. Kung makikita mo dito, ito yun. No? This is a contraceptive. Okay. Next is we have your Naegleria fowleri. Of all, si Naegleria fowleri yung magandang tandaan. Bakit? May tatlo siyang morphological form. Bakit ba? Meron siyang cystic stage, meron siyang trophozoite stage, and at the same time, meron siyang flagellated trophozoite. Ano daw? Flagellated trophozoite? Yes, you heard it right. Meron po siyang flagellated trophozoite. So, ibig sabihin, may flagella din yung sa trophozoite. Okay? Flagellated form of our Naegleria fowleri appears a pear-shaped flagellate. Okay? And it is equipped with whip-like structure. Whip-like structure that is their flagella. And the motility of this is jerky movement. Okay? Nucleus is basically identical to amoeboid trophozoite. No granular cytoplasm. Okay? So this is the amebic or the amoeboid trophozoite. This is the flagellated trophozoite. And this is the cystic stage. Ano yung mahalagang tandaan dito? Yung ating Naegleria fowleri, meron siyang makapal na cell wall. No? Meron siyang makapal na cell wall. And like what I've said, Naegleria fowleri is an extraintestinal parasite and capable of what we call primary amebic meningoencephalitis. Kanina, yung secondary amebic meningoencephalitis is diarrhea with abnormal mental uh, condition. Naegleria fowleri, no, primary amebic meningoencephalitis. And remember, si Naegleria fowleri yung merong tatlong morphological forms. Ano po yung sample of choice? Sample of choice is or diagnose laboratory laboratory test, microscopic examination of the CSF. Oh, hindi na stool, CSF, no? Smears of iodine and wet preparation is useful usually for the trophozoite, no? Nasal and tissue discharge can also be a sample of choice. Now, remember that the only form that exists into human is the amoeboid trophozoite. And this is also the infective stage to human. No? And swimming in contaminated water and entry into the nasal mucosa is the mode of transmission of this parasite. The entry in the mucosal area will allow them to migrate into the brain, causing primary amoebic meningoencephalitis. So ito po yan. No? This is the life cycle. The cystic stage that is present in the body, in the water body, no, morphologically transform into trophozoite. This trophozoite, no, can transform into what we call flagellated form. Remember that the the amoeboid trophozoite is the infective stage to human, and there will be someone who will swim, no, and will entry into its nasal mucosa, penetrate the mucosa, and then the amoeba or the amoeboid migrates into the brain via olfactory nerves, causing primary amebic meningoencephalitis. Trophozoites can be seen in the CSF and brain tissues, flagellated forms occasionally in CSF. No? What is primary amoebic meningoencephalitis? This is a condition wherein the brain is being invaded and it is characterized with rapid tissue destruction. The patient may experience fever, headache, sore throat, and nasal, and as well as vomiting. Symptoms of meningitis includes stiff neck and seizures. Okay? There's also a loss of smell and taste. No? Bakit? Apektan yung olfactory nerves mo eh. No? And there is what we call Kernig sign. This is a characteristic of meningitis, which is you are unable to straight your legs. And sad to say, primary amoebic meningoencephalitis is capable of causing death. Treatment is amphotericin B. Nagagamot, yes. Rifampin can also be used. Naiwasan ng pagkamatay, oo naman, kung magagamot ng agad. Okay? Ano po ang ginagawa ni amphotericin B at minikinazole? No, it damaged the cell wall of the Naegleria. That's why no, the synthetic or the genetic material of the Naegleria fowleri can be destroyed. Rifampin naman, yung ini-inhibit niya yung RNA synthesis ng ating Naegleria fowleri. Another one is we have your Entamoeba species. No, there's also a cystic stage and a trophozoite stage for Entamoeba species. No? Kung matatandaan mo, sabi ko sa inyo, si Naegleria fowleri, meron siyang thick cell wall. Ito naman si Entamoeba histolytica, si Entamoeba, meron siyang double cell wall. At ang magandang tandaan doon, rugged pa yung kanyang cell wall. Okay. This illustration shows the presence of our Entamoeba. No? Meron siyang flagellated form and meron siyang cystic form. Ito yung sinasabi ko sa rugged. No? Rugged edges. I'm sorry. rugged edges ng kanyang cytoplasm or ng kanyang cell wall. Double-celled wall, the outer cell wall is rugged. Okay, again, the specimen of choice is CSF. The same thing with our Naegleria fowleri. Yeah. Cornell scrapings can also be used, and it can be cultured in a non-nutrient agar with gram-negative Escherichia coli. O ito lang, teka lang ha. Baka kasi sabihin yung E. coli, si Entamoeba coli po ba yan? No, this is Escherichia coli, a gram-negative bacteria. At ano naman yung purpose ng E. coli dyan? Serves as the nutrients for our Acanthamoeba. Okay? Again, remember that the life cycle includes the aspiration of the nasal inhalations and direct invasion of the parasite to the eye, no? As well as swimming in contaminated water. So yeah, no, from cystic stage, trophozoite stage, no, nagmamitosis for the division. Trophozoite stage is also the infective stage of our Naegleria fowleri and Acanthamoeba species. Diba? Kanina, dun sa Entamoeba histolytica, cystic stage. Pagdating kay trophozoite, pagdating kay Acanthamoeba at kay Naegleria, ang infective stage na is sino? Si trophozoite. No? The amoeba and the cyst can enter into various ways. It can be sa lungs, it can be sa mouth, it can be sa nasal. No? Causing ulcerated, or it can also transmit using ulcerated or broken skins. No? So pwede sa lungs, pwede sa brain. No? Which can result into severe keratitis of the eye, or what we call granulomatous amebic encephalitis, GAE. May SAM, may PA, may GAE. No, granulomatous amebic encephalitis is for Acanthamoeba species. Okay? So what is GAE or granulomatous amebic encephalitis? Ayan, kung makikita nyo dito, meron siyang abscess doon sa ating brain. Now, this is a CNS infection caused by Acanthamoeba species. So again, what are the signs and symptoms? Headache, seizures, stiff neck, nausea, and vomiting. Lesions in the brain is also seen. Invasion in kidney, pancreas, and prostate is also possible. We have what we call Acanthamoeba keratitis. This is what I am telling a while ago. This is an infection of the cornea of the eye. There is what we call ocular pain and loss of vision is possible. Treatment is almost the same thing as with our Naegleria fowleri. And that is the end of our discussion. Thank you very much, and I hope you learned in this lecture.